Okay, so let's take a look here. So we have a hypothesis test we're doing with alpha equal to 0.10. Um, our null is that the two means are equal, and our alternate is that mean 1 is greater than mean 2. We believe they are normally distributed, but we don't know the standard deviations. Let's see. We also have no reason to believe the variances of the two populations are not equal. We obtain a sample of size 22 for our first sample with a mean of 67.4 and a standard deviation of 9.7. And then we obtain a sample from the second population of 13 with a mean of 54.3 and a standard deviation of 19.1. Okay, so let's look at the critical value. So it says to use the conservative underestimate. Now, all this means for our degrees of freedom, we're going to use the t distribution because our sample sizes are small. But for the conservative underestimate we use for the degrees of freedom, we look at the smallest sample, which is the 13, and we just subtract 1. So our degrees of freedom are 12. So we are going to look up, since this is a one-tailed hypothesis test, we're going to look up 0.10 and degrees of freedom 12 in Excel using the t distribution. So I'll go over to Excel, equal t.imb, and I'm going to put 0.10 in, and I said 12 were the degrees of freedom, and we get negative 1.356. Now that's the left tail, and since it's a greater than for our alternate, we really want the right tail, so we want 1.356. And I think it wanted us to round to 3 decimals. So yeah, so it's 1.356. All right, now test statistic. Let's see where you're going wrong here. Um, all right, now since these are small samples, we have to be sure that we're using the test statistic for small samples. And I apologize, my dog is growling at the other dog in the background. Um, so I'm going to go to, I pulled it up, our formulas document. And of course, this is also in your textbook, but notice the small sample test for hypotheses for mean 1 minus mean 2. Here's our test statistic. We've got to use this right here. Um, and then we're going to have to use this pooled variance formula. You'll notice that part of this is we've got that pooled variance right there. So let's first do this pooled variance calculation. And I think it will let me write directly on this, maybe. Oh, there it is. Okay. All right, so I'm going to use that formula with our information. So our pooled variance for the information that we have that the first sample size was 22. So we have 22 minus 1, so that's going to be 21. And our first standard deviation was 9.7, so we want to square it. And then we have the second sample size was 13, so 13 minus 1 is 12. And then our second standard deviation was 19.1, so we want to square it. And we want to put that over first sample size plus second sample size minus 2. So our first sample size was 22. Our second one was 13. 22 and 13 is 35. Minus 2, this is going to be 33. And when we let our calculator do this whole operation, we end up getting 192 0.53364. So it's rather nasty. All right, now that's the first part. Now we've got to do the actual test statistic. Now, since we had for our null hypothesis that mu1 minus mu2 were equal, or mu1 is equal to mu2, which is really the difference is 0. So we'll have our first mean minus our second mean minus 0. So we really don't need to put the difference there. So our first mean minus our second mean, let's see. I didn't write down the two means, but if we subtract our two means, we get 13.1. Two sample means. So I think it listed them as M1 and M2. All right, now on the bottom, we want this variance that we just got right here. I apologize for my bad first grader like handwriting on the screen. And then 1 over the first sample size. First sample size was 22. And 1 over the second sample size. Second sample size was 13. And the one thing you want to make sure of when you put this in your calculator is that you put parentheses around it like that, because that can end up giving you the wrong answer if you don't get that 192 kind of in an entire set of parentheses like that. And when I stick this thing into the calculator, I get 2.699, which is our test statistic. And let's go back here. So that was 2.699. I'm going to go back to, oh, I think I have to exit the drawing mode here. All right, so since our critical value was 1.356, and remember, since this is a greater than, wait, I know my curve, this is our 1.356 is over here. And certainly 2.699 is in this region over on the right, so it is in the critical region, so we reject the null, which means, of course, that we have enough evidence to show that this alternate is true. And hopefully that will help you get through these.